Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we review everything you need to know about linear relations for the upcoming test. So what do we mean by linear relations? Well, we're looking at the relationship between two variables. Usually we call them x and y. What makes that relationship linear? Well, it turns out in the first one, the relationship's linear, but in the second one, it's non-linear. See, what's happening here is each time x is going up by 1, y is going down by 2. Each time x goes up by 1, increases by 1, the y value decreases by 2. The same thing is happening to y each time. We are adding or subtracting the same amount from the y value each time. That's exactly what we mean by linear. Now this number that you're adding or subtracting each time, in this case -2, is called the gradient. So we can define a relationship as linear if the gradient is constant. You are adding or subtracting the same amount each time. Here the gradient is -2, it's the same each time. Whereas in this table here, I'm still adding 1 to x each time. That hasn't changed. But look what happens to y. First I add 3, then it goes up by 5, then the y value goes up by 7, then it goes up by 9. Here, the gradient is changing each time. It's a non-constant gradient, so this one here is non-linear. We're not looking at non-linear, we're only looking at linear, but it's important you know what we mean by linear. Now, why do we call such a relationship like this linear? Well, it turns out if we were to plot each of these in the Cartesian plane, it would form a line. So each of these is a point. This is the point -2, 9. So let's plot it on the Cartesian plane. So this is the Cartesian plane here. Remember, the y-axis is always the vertical and x the horizontal. To plot -2, 9, you go across to x is -2 and then up to y equals 9. It's that point there. And then we could plot the next point, -1, 7. So we'd go across to x is -1 and up to y equals 7. The next point, we could plot x equals 0, y equals 5. So x equals 0 is here, y equals 5 is there. And if we plot 1, 3, x equals 1, y equals 3, it's there. The points lie in a straight line. That is why it's called a linear relationship. Were you to plot the ones in this table, it would not be a linear relationship. It'd actually be a curve that goes up like that. All right, let's now look at plotting a line when you're given the equation. So the kind of thing you need to be able to do is get an equation like this, y equals 2x plus 1, and turn it into a graph. So how do you do that, and what is the graph? So note here, we have an equation with two variables. This has infinitely many solutions. One such solution, for example, is x equals 1, y equals 3. If you substitute x for 1, you get y equals 3. So this is a solution to the equation. That means that 1, 3 is a point that does lie on this line. Something like 1, 4 does not lie on this line, because if you substitute x for 1 and y for 4, you get an untrue statement. 4 equals 2 times 1 plus 1. That's just complete nonsense. So what this graph is it's infinitely many points. It's the set of all the points that have an x and a y value that make this a true statement. Another point that would lie on this line, if x equals 5, y equals 11. 11 equals 2 times 5 plus 1. That is a true statement. Okay, so how do we actually find all these points we need to graph? Well, we don't want to just do random ones like this. What we can do is draw up a table of values. So the table of values is actually what you saw on the screen on the previous slide. So when you're doing a table of values, you can choose the x values. So you can just always choose, if you like, x from -2 to 2. How do you find the y value that goes with the x value? Well, you just substitute it. So if x is -2, y is 2 times -2, -4, plus 1 is -3. You can use your calculator. If x is -1, y is 2 times -1, plus 1, which is -1. You can do that for all of these points here. You just take your x value, substitute into the equation to get the y value. Now note here, this is linear because this time, each time x goes up by 1, y is going up by 2. The gradient of this line is 2. No coincidence, it's 2 because that number there was 2. So how we turn this into a graph, we simply plot each of these points. So let's start by plotting -2, -3. So we go across to x is -2, down to y is -3, which is about there. And next we plot -1, -1, which is about there, 0, 1, 1, 3, 2, 5, and so on. Now, when you've plotted the points, you simply draw a line through them. Your line needs to have arrows on each end because a line goes forever in both directions, and you should write the equation. This is the line y equals 2x plus 1. Each of these is a point. A line is just a set of all the points where the x and y value make this a true statement. All right, now we're going to graph another line, and I'm going to show you a quicker way to graph that you may or may not like to use. So we're going to graph y equals 1 minus a half x. Now you could, just like on the previous slide, draw up a table of values if you like. There's no problem with that, but there is a faster way. See, it turns out on the previous example, we actually plotted 5 points. You actually don't need 5 points, you actually only need 2 points. As long as you know 2 points, then you can graph the line easily. So when you're graphing a line, as we pointed out before, this number in front of x is the gradient. The gradient is rise over run, and it turns out the constant, the number not connected to x, is the y-intercept. If you know the y-intercept and the gradient, you can graph a line. So how do you do that? Well, what you do is you plot the y-intercept. So the y-intercept is where the line hits the y-axis. So it's 1 here. And the gradient here is -1 over 2. Now, gradient is rise over run. This number on the bottom of the gradient tells you how far you go right, and the number on the top of the gradient tells you how far you go up or down. So what we do is we start at our first point here, which is the y-intercept that we graphed. So after you've graphed the y-intercept, you use the gradient to find a second point. So this is telling us we go 2 to the right. Now, if this is a positive gradient, you go up, and negative, you go down. We go 2 to the right and we go 1 down. So the line actually goes through that point there. So the reason we went 1 down was because it's a 1. The reason we went down and not up is because this is a negative there. So once you've got 2 points, all you need to do is draw a line through them, make sure there's arrows on your line, and that you write the equation. So there is a trade-off here. This method I've just shown you is much more complicated to understand than the table of values in the previous example, but it is much quicker. So which of those methods you want to use doesn't worry me at all. All right, let's now look at finding the equation of a line. So at standard, students can take an equation and turn it into a graph, like I showed you in the previous 2 examples. But if you want to be above standard, you need to be able to do the opposite. You need to be able also to reverse the process. So that means you need to be able to get a graph and find its equation. Now, even though this is above standard, it's actually not hard to do. It turns out, unless the line is perfectly vertical, its equation will be of the form y equals mx plus b. So all you need to do to find the equation is find m, which is the gradient, and b, which is the y-intercept. So let's look here. We are going to find the gradient and the y-intercept. So remember I said before that the gradient is rise over run. Run is how far you go to the right, and the rise is how far you go up or down. So you need 2 points to find the gradient. So let's look at these 2 points here. Now, always start at the leftmost point because you need to go right. So to go from this point here to this point here, you need to go right 2. How did I know it was 2? You're going from -1 to 1. The difference, the distance between them is 2. to go from here down to here, you actually need to go down by 6. So why is it 6? So from -2 to 4 is 6 units. 4 subtract -2 is 6. Why did I put a minus here? Because as I said in the previous slide, when you're dealing with the gradient, if you go down, the gradient's negative. If we went across and up, the gradient would be positive. So the gradient here is actually -6 rise divided by run. -6 divided 2 is -3. So the equation of this line is going to be y equals m times x plus b. All that remains is we now need to find b. So how do we do that? Well, because this is a line, it has a constant gradient, and we just figured out it's -3. So if you go 2 to the right, you must go 6 down. A gradient of -3 means if you go just 1 to the right, so x increases by 1, you must go down by 3. So 4 minus 3, if you start at 4 and go down by 3, you end up at 1. The y-intercept here has to be 1. So we rub out b and replace it with 1. This is the final answer. This is the equation you would need to start with to end up with a graph like that. All right, let's now look at some linear modeling questions. So linear modeling is basically just us applying what we know about straight line graphs to solve real problems. So an example would be a distance time graph, so called because we have distance along the y-axis, time along the x-axis. So this is the distance time graph for a run I went on this morning. So let's look at what happened. So I started here, obviously after 0 minutes, I hadn't run any kilometers at all. So I just ran. Now because this is a straight line, constant gradient, it means I was running at a constant speed. So for the first 30 minutes here, I ran at a constant speed and I ran 5 kilometers in total. So after that, I then had a rest. I'm not traveling any distance here, so I must be resting. So I've rested for 15 minutes. Now I'm going down. This means I'm going in the other direction. So what happens is I must have run like 5 kilometers to a park or something, rested, then I turned around. So actually what's happened is the total distance covered is 10 kilometers. I ran 5 kilometers there and 5 kilometers back. So let's look at the speed. A question you might get asked is, at which point was I traveling the fastest? Well, it turns out the speed is equal to the gradient. So when I'm asking when was the speed the largest, I'm asking for which part of this graph has the highest gradient. So higher gradients mean the line is steeper or more vertical. So that's essentially what I'm being asked. I'm being asked here, where is the line the steepest? So you might be able to see the answer just by looking at it. Maybe you can't. So let's actually look at calculating the speed. So if I look at the first 30 minutes, in that time I traveled from 0 to 5 kilometers, I traveled 5 kilometers. So lucky we did all this work on ratios and rates. 5 kilometers in 30 minutes is the same as 10 kilometers per hour. That was my speed for the first 30 minutes. Now, obviously, my speed is 0 when I'm resting because I'm not traveling. So what is my speed for this part? Well, what I've done is from 45 minutes to 60 minutes, I've gone 5 to 2. I've actually traveled 3 kilometers in this time. I just traveled 3 kilometers in the opposite direction, running from the park back home. So from 45 to 60 minutes, I traveled 3 kilometers in 15 minutes. So 15 minutes is a quarter of an hour. You times by 4, that's actually 12 kilometers per hour. So what about between 60 and 75 minutes? So that's this part of the journey. I've traveled from 2 to 0. I've traveled 2 kilometers running from the park home. So if you travel 2 kilometers in 15 minutes, once again, 15 minutes is a quarter of an hour, times by 2 by 4, you get 8 kilometers per hour. So clearly it's this part of the journey at which I'm traveling the fastest. And that's because this line is steepest. This line is a little steeper than this one, and it's a lot steeper than that one. All right, let's now look at another modeling question. So originally there is 1 kiloliter or 1,000 liters of water in a tank. Water flows out of the tank at a rate of 40 liters per minute. We're going to graph the relationship between V and T and calculate after how many minutes there's only 100 liters left. First, let's graph the relationship. So V is the volume. It's going to go here. If you have time as one of your variables, it always goes on the horizontal axis. So originally there were 1,000 liters in the tank. So you don't need to go and measure up, 10, 20, 30, all the way to 1,000. You can just estimate 1,000 can be there. So if there are 1,000 liters and it's flowing out at a rate of 40 liters per minute, well, 1,000 over 40 is 25. It will be empty after 25. So after 25 minutes here, there is no volume, because here would be volume equals 0. Now, because the water is flowing out at a constant rate, which is 40 liters per minute, the rate doesn't change. This graph is going to be a straight line. Now, on this particular graph, I'm not putting any arrows because the graph doesn't continue. You can't have negative time, and here the tank is empty. You can't lose water if the tank is empty. The water won't keep flowing out. That's why the graph stops here. This is actually a line segment rather than a line. So this is what the relationship looks like. So after how many minutes is there only 100 liters left? So what we're really asking is, when we have 100 as our volume, what is the corresponding value for time? So that's not easy to find when we've drawn the graph ourselves, but we can easily find the equation that models this. See, the volume in the tank was originally 1,000, but we're losing 40 liters every minute. Here, T is minutes. So the volume in the tank after T minutes, it's 1,000 minus 40 times the number of minutes it's been leaking out. So if we want to find when the volume's 100, we just substitute V for 100. So we have 1,000 minus 40t equals 100. We've solved equations like this a million times. First thing we're going to do is subtract 1,000 from both sides. Then we're going to divide each side by negative 40. You actually get 22.5 equals t. That means there will be exactly 100 liters left after 22.5 minutes. So I want you to understand the link between the algebraic and the graphical here. The solution to this equation, we are just finding the value of t when V equals 100. So graphs can actually be useful at solving equations as well. All right, let's look at one harder example, then we're done. So I am paid a fixed amount per shift plus an amount for each bottle of fragrance I sell. If I sell 4 bottles, I'm paid $150. If I sell 8 bottles, I will be paid $210. How much will I be paid if I sell 15 bottles? Okay, so here we have a linear problem. The reason it's linear is because I get the same amount for each bottle of fragrance sold. So each time you increase the number of bottles by 1, you increase the amount of money I get by the same amount. The gradient here is constant. It's a linear problem. Okay, so let's look. If I sell 4 bottles here and I am paid $150, whereas if I sell 8 bottles, I will be paid $210. So here what's happened is we have added 4 more bottles and we have increased pay by $60. So the gradient here is 60 over 4, which is 15. What does that actually mean? Well, what it means here is that each time I sell 1 bottle, I increase the pay I get by 15. If 4 bottles gets you $60 more, then 1 bottle will get you $15 more. So I had 8 bottles and I got 210. So if I increase the number of bottles I sell by 7, if I now sell 15 bottles, then what I have to do is I have to increase by 7 times 15. Now 7 times 15 is 105. So I will end up getting 210 plus 105, which is $315. So I found that each bottle gets me $15 more, so 7 bottles will get me $105 more. That's how I was able to figure out this one. Alright, thank you so much for tuning into this video. Best of luck studying, but you will ace the test, you're a star. This has been the luckiest maths teacher in the world. Have a great day.